Hi everybody, my name is Zach. I'll be talking about some important things that we'll be talking about in PChem later on in the semester. One of those things is going to be an equation, another is going to be a particle, and finally the last thing I will talk about is one of the main forces that we'll be introducing later on. First thing I want to talk about is Schrodinger's equation. Pretty much everyone has heard of Schrodinger because of his famous experiment with a cat that he locked in a box with a poison vial, basically saying there are infinite possibilities that could happen. We don't know until we look. But we're going to be talking about his equation real quick. This equation is basically used to describe changes over time in a system in which quantum effects are very significant. Prime example is wave-particle duality. This equation was developed in the 1920s by Schrodinger, but it did not win him a Nobel Peace Prize until the 1933. Next, we'll be talking about Higgs boson particles. They have a lot higher mass than any other boson particle. Another thing that they have different than a lot of the particles is they have no spin, no electric charge, or color charge. I like the picture that I shows down at the bottom because they are very unstable and they do decay into other particles, which cause those particles to have a higher mass, as you can see in the little comic strip I put there. Finally, I want to talk about gravity. This was first discovered by Newton. Everyone knows that. Apple falling on its head. Oh, there's gravity. And he came up with the laws of gravity right there. But this doesn't just apply to small objects, it applies to large objects, including solar systems and universes.